We're asked to find what concentration of sulfuric acid will remain in a final solution after we've neutralized sulfuric acid and the potassium hydroxide here. We're given the equation and the molarities, but let's note something interesting here. So we're looking for this answer, mole over L. That's what the final answer should look like. The final solution is going to essentially be this total liters down here. Well, what's the total liters? If we're mixing 0.45 with 0.4, then we should know that the total liters at the very end should be equal to 0.850 liters. And then we just need to figure out what mole of H₂SO₄ we have. Now we should note that if we're trying to react 1 mole of H₂SO₄ here, we get 2 moles of KOH, and that is the ratio. So we need 1 mole of H₂SO₄, and we need 2 moles of KOH to react. Now, let's see how many moles we've actually got. So for H₂SO₄, let's take a look. We're given the molarity. That's mole over liter already. So we know that 0.470 mole of H₂SO₄ divided by the liters, which is probably just 1 liter. But that's the conversion factor. We want to know if we have 0.450 liters of that stuff, what's going to remain if we multiply these two things? The liters will cancel, and we're going to be left with how many moles of H₂SO₄ we have. So we're closer to getting the answer over here, at least. Let's do that multiplication there. So 0.470 times 0.450, that's just going to be equal to 2115. We should have only 3 significant figures in this, though. So 0.2115, but I'll mark that third one there. Now we'll move on to the next one, which is KOH. So for KOH, we're given the molarity as well. So we know that 0.250 mole of KOH, and we can divide that by 1 liter there. Then we can multiply that by how many liters we have. So that's 0.400 liters. And if we get these things to cancel, then we should get the moles of KOH that we have. Let's try to do that multiplication. 0.4 times 0.25. That's 0.1, but we should have 3 sig figs here. So 0.100. And this is the mole of KOH, whereas this is the mole of H₂SO₄. Now, we should see that this is the conversion factor. So, we really need a lot of this stuff. Note that we need 2 moles and just 1 of that. So why don't we figure out if we go 0.100 mole of KOH, and we multiply that by this conversion factor. 1 mole of H₂SO₄ divided by 2 mole of KOH. Notice these 2 will cancel out, and we're just going to be left with how many moles of H₂SO₄ reacted with that. So 0.1 divided by 2. That's basically what that's looking at. So 0.05. But we also have to count the significant figures. I think we got 3 in there, so let's add 2 more zeros. And this is the mole of H₂SO₄ that has so far been reacted. But there's a whole bunch that hasn't been reacted. So let's figure out that math. We're going to go 0.2115 with the third decimal there, mole of H₂SO₄ minus 0.05, a whole bunch of zeros there. There's only 2, but there we go. Mole of H₂SO₄. That should give us some kind of answer. So 0.2115 minus 0.05. And we get 1615. 0.1615. This is the mole of H₂SO₄ that has not been reacted yet. So that is what is left. However, let's figure out what the sig figs are. If we subtract, here we have 3 decimals. So the answer should have 3 decimals. And we're not done yet, so we need to divide this by the liters. So let's go ahead and do that. Divided by 0.85. And since we've divided by, let's see, we have 3 sig figures divided by 3 sig figures. The answer should also have 3 sig figures. We have 0.19. So I believe that the final answer is that the molarity is 0.190 moles over liters. That's the molarity of H₂SO₄ in the final solution. Here we go.